Okay, so experimental chemistry, we start normally the syllabus with of GCO levels or IGCSE or Excel. Okay, here chemistry syllabus basically for O-level students. Okay, when we say chemistry, it is an experimental science. Chemistry has to do something with experiments, with practicals, to make something, to produce something. And chemistry has huge uses around. You see, it's chemistry that actually helps us make things, like the marker in my hand. Its plastic body is designed by a chemist, polymer chemist. Get that? Polythene, high density polythene it is. Or when we fell ill, even simple headache, you need Panadol. It's being manufactured by a chemist. Its concentration is being set by a chemist. Or you want to see colors, plenty of colors. Look at the color right here even. Plenty of clothings, dyes, like azo dyes, okay, strong dyes made by chemists. You want to get rid of the insects and pests and want to stay clean, insecticide and pesticide made by chemists. Okay, or plenty of other comforts are given by chemistry, like you're feeling warm and air conditioner contain the gas and the body it has made by chemistry. Okay, plenty of life-saving drugs, plenty of cosmetics makes you look better, and plenty of clothings we wear, all chemistry designed. The car, the interior of the car basically, the dashboard, polybutene, chemistry. Synthetic materials, colorful world this is. You enter into a supermarket, you find so many stuff, chemistry makes it. Anyhow, huge applications, long discussion. So chemistry, the basic of experimental science, and to be a chemist is being a professional qualification. You make medicines, you go to the pharmaceutical industries, you go to the dyes and insecticides and pesticides and plenty of other varnishes and polishes and stuff. Okay, so huge applications chemistry have in the daily life, industrial chemistry, and the chemistry used in the household products like cleaning agents and detergents and varnishes and sticking stuff and glues. Okay, but chemistry has plenty of things to do with experiment. So you enter into a chemistry lab, you find out plenty of apparatuses and weighing things and stuff and all that. When we say chemistry, basically it is a study of matter, what it is, its composition, and how it will react, its chemical properties, and how it will physically behave, its physical properties. So chemistry is the study of composition of matter, its chemical properties, its physical properties. Okay, so we can use that material. Okay, we can interact that material. For that, experimental it is. So we need some experimental setup or a lab. And to simple measurements that we do in the lab, mostly chemicals are used in liquid forms. And we need to find out their volume. When we say space taken up by that liquid, the volume. And SI unit internationally, it is cubic meter, but we seldom use that. We're going to normally measure small volumes, so we use centimeter cube, 1 centimeter cube, 1 ml, they are equivalent, or 1000 cm cube, 1000 ml it is written, or it is 1 dm cube, mean it can be normally taken as 1 liter, 1 dm cube is equal to 1 liter, give us 5 liter petrol we say, mean 5000 cm cube. And common apparatuses that we use for measuring liquids, it include for accuracy, for very much accuracy, very finely calibrated, okay, huge accuracy, it is pipette. And pipette measures only fixed volume, or in multiple of 5 cm cube pipette, 20 cm cube pipette, 25 cm cube pipette is most common. And you suck a liquid right from here till this point. And for that we need something to suck the liquid up safely. Because if we do it with mouth as it has been done in previous years, 2 decades back or 3 decades back maybe, there was dangerous sucking it up with and keeping a hand up, because the liquid can go into the mouth. So these days they'll ask you what safety item you use, you say safety filler item. It is the rubber bulb. It has a mark for sucking and mark for ejection. Okay, the bulb pipette, you call it as bulb pipette. The safety item you need to remember, and pipette, fine calibration, but only one mark. Start sucking in from here until, look at the calibration mark. It cannot be here, remember, it is always here. To fill up till here, till that mark. Okay, because graduation questions you will find out that where the mark should be, what the safety item must be. You will say the rubber bulb. Okay, usage of the bulb you will learn in the lab, that how we suck the air out and we put in the S button, and then we press in the E button to adjust and S button to take it up, and then fine, we note down that how much volume is being recorded. Fine pipette for accurate, for titration especially, for volumetric analysis, for volume analysis. Another accurate instrument, more handy I should say, because it measures varied volumes from 0.1 cm cube, 50 cm cube. Burette can be of 100 cm cube as well, but normally it is till 50 cm cube. Between 0 and 1 there are 10 divisions. 0.01 cm cube can be the accuracy. Okay, so you can measure any odd value from 0 to 50. Pipette fix, this can measure any odd value. Okay, so more handy, and you can add varied volume. Often the question says, what do you use to measure the varied volume? You say it is burette. Look at the burette coming with a tap. So you can control that with any time. And look at that, any volume you can find out. The scale starts right from here. Scale can be called as upside down. So you can run in and you can find out how much volume has been run in. So initial and final minus subtraction of initial volume to final volume will tell us, or final volume minus initial volume will tell us what? The difference, and that will be the volume basically you have taken from the using the burette. Okay, like you run in from 0 to 15 cm cube, 15 cm cube minus 0, it means you have taken 15 cm cube, and you need 35 cm cube, it means you run in from 0 to 35 cm cube. You need 15 cm cube, never do that, you run until 35 cm cube and you say the 15 is left behind. Okay, basically you run in the volume and find out how much was the initial reading and what is the final reading, and subtraction of those two. Remember these tips. Okay, student make funny mistakes right here. You need that volume, you run that volume out. Run in it, if its initial reading is 5 cm cube and you need 20 cm cube, it means you run in from 5 cm cube till 25. 25 minus 5 cm cube, 20 cm cube taken it. Okay, use this carefully, basically the knob. Okay, find out, care for every drop that fall in. Accurate volumes I said, but if sometime the accuracy is needed up to 1 cm cube, you need certain 1 cm cube accuracy, not that much accuracy like in titrations. You can use the measuring cylinders, very handy measuring cylinders, because from 5 cm cube to 5000 cm cube you will find out these variety of cute measuring cylinder in the labs. Okay, I said from 5 cm cube till 5000 cm cube, and it is 1 cm, it is accurate till 1 cm cube. So between two divisions, if the liquid falls, you can take the upper meniscus and you find out 0.5 cm cube can be actually gauged in, like 55.5 roughly you can take, but 1 cm cube basically is the lowest division. It states, okay, sometime you are given a concentrated solution is a bit strong and you need to dilute it because you want more stock solution. For dilution, to add distilled water and make a diluted solution, you'll use a dilution flask. Okay, look bit like this, and dilution flask basically actually has only one mark. Okay, it has a long narrow neck, basically maybe longer than this basically, and it is used basically to prevent liquid splashing out and make a careful solution, diluted solution, stock solution. Okay, and if you want to measure gases, and in many experiments like metal acid gas is produced, a metal carbonate acid gas is produced, okay, or ammonium compound and alkali gas is produced, or you decompose a substance, possibly the gas may be produced like potassium carbonate, sodium carbonate, carbonates. Potassium, sodium are very reactive, you can use copper carbonate for decomposition or other less reactive. If gas is produced, then you can find out the volume of the gas by using the gas range. Very soft gas range, soft light little plunger it has. As the gas is being produced, the plunger moves backwards, and you can find from 0 to 50 or 0 to 100 these gas ranges are available in the market. Okay, so another very sensitive instrument normally must be of a high quality, the gas range. To measure gases, to measure liquids, these are To measure liquids, you will find variety of little things in the lab, like the beaker. Beaker is not to measure, basically to keep chemicals, to mix chemicals, because it has very poor graduation. But finely calibrated instruments are these, and to some extent that beaker, okay, measuring cylinder. To measure mass, solids, you use digital scales, electronic scales. They are available in wide variety from 0.01 gram 0.01 gram the accuracy. Kilogram is the SI unit, but normally we use small volume, measure small masses. So 0.01 gram the accuracy it has, but you measure in grams, okay. When I say mass, it is quantity of metal in a body, okay. Electronic balances are very handy these days available, so the top pen balances or beam balances are no more that common. You have plenty of digital electronic balances, maybe accurate 0.01 or more than that, okay. So mass, quantity of metal in a body, how much weight you want to weigh it, use grams basically, and grams we measure, okay. 1 gram, okay, maybe sometime you can take it as equivalent to 1 cm cube as in liquid, okay, but 1000 gram is equal to 1 kg. 1000 grams is taken as 1 kg. Kg is the SI unit, but normally we use grams. And to make things simpler and easier, okay, we use the computer data loggers, okay, because they make things quite easy. Look at data loggers these days are common in high-tech labs normally, because always the human presence is not needed. You want to measure the pH, you want to measure the pressure, temperature, you feed in the data and you work with the sensor, put the sensor in the right place, and it will sense, it will record, and whatever you have actually instructed in, you'll find out that that is being recorded, it's being tabulated, and you can get a printout of it, okay. So data loggers normally come with the computers and with what? With sensors, and definitely with interface that connect these two apparatuses, sensors and the computer, your recording stuff. So your automatic recording stuff is what? Data logger. Data loggers is used to record the data without always the human presence. So normally these are the measurements you can use. Apart from these, you want to measure time, you can use stopwatches. Digital stopwatches are very much common. Time you can measure, or you want to measure basically pH, you have pH sensors, you have pressure sensors, and you can link them with the data loggers. And you want to even measure a very small amount of the liquids and very accurately, as the doctor has, you have the hypodermic syringes, okay. So in the lab you'll have plenty of apparatuses, but to measure accurately these are, otherwise you have plenty of other apparatuses just to heat chemicals and to mix chemicals, like flasks, round bottom flasks normally to heat, okay, or flat bottom flask also, and plenty of other apparatuses are there, reagent bottles just to keep chemicals. But when you want to measure out accurately, you have pipette, you have burettes, you have measuring cylinders, record gases, you have gas syringes, and you want to make dilution solutions, you have dilution flasks, okay. So chemistry is very interesting, very handy, but experimental chemistry starts with the apparatuses, basic apparatuses you need to know and you need to work with in the lab, okay.